So the first method of factoring we're going to talk about is using a greatest common factor. So we're going to talk about finding the greatest common factor first, and then how to actually factor it out of our polynomial. So if you think back to elementary school, when we're looking for the greatest common factor, remember a factor is something that you can multiply by another factor to get the original value. So right here I have a list. It says factors of 12. So all of these are factors of 12 because 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Okay, so those are all individual factors of 12. Down below, I've got factors of 16 listed. So if I'm looking for the greatest common factor, common means that they share the factors. So they both have a 1, a 2, and a 4. And then when we say the greatest one, we're looking for the largest one they share together. Okay, so that's basically the elementary version of GCF. When we're talking about GCF and Algebra 2, it's just involving variables as well. Okay, so the GCF of 6x and 9x squared. What is the largest factor of 6 and 9? What's the largest? 3, okay? Because factors of 6, we could say 6 you can get by 1 times 6 or 2 times 3, right? 9, you have 1 times 9 or 3 times 3. So the biggest number they have in common is the 3. Now, what is the largest variable piece that they have in common? Just a single x, okay? Because my x squared has 2 x's. So you could say that this one is x times x. My 6x is just a plain x. We want to know the greatest number that they have in common. So that's all that we can pair up. There's not a second x. So we can say that the GCF for this is going to be a 3x. So when we're factoring that out, we're going to be factoring out a 3x. Okay, let's skip down here to example 3. Okay, so we've got 3 different things we're finding the GCF of. So when we talk about common, it has to be common within all 3 of these. Can anyone tell me what they think the largest value for our coefficient is that they all 3 have in common? By 6. Okay, so 6 for sure will go into 54 because that's 9 times 6. 6 times 6 is 36, and 6 times 5 is 30. So that's for sure a common factor. Can 30 be divided by 8? No, so 8 won't work. Pretty much 30. We have 1 and 30, 2 and 15, which 15 is not a factor here. 3 and 10, 10 is not a factor here. And then 5 and 6. So we said 6 is the greatest common factor, okay, for our coefficients. I agree. Now let's look at our variable pieces. So for my x's, I have an x, 2 x's, and 3 x's. Because remember with our exponent, x cubed means that there's 3 x's multiplied together. X squared and x. So what is the greatest number that they have in common? Just one single x. So I've got an x. What about for my y's? Just one single y. And then for my z's? Okay, so here I've got z times z times z. Here I've got z times z. And then here I've got z times z times z. I've got 1, 2. Yep, that's exactly what it is. So here I have a z squared that they have in common. So like he was saying here, he says you're just looking for the smallest exponent out of all of them because that's the most that you can take out. Because if I tried to take 3 from here, there's not 3 there, okay? So we can only pull out whatever the smallest exponent is. Now, what if it was like this and there was no z here? Could I bring out any z at all? Could I say, okay, well, between these two, z squared is the smallest, so I'm going to take out z squared? No, because common means it has to be in all 3. So if one of them is missing a certain variable, that's not going to be part of your GCF at all. So we would say the GCF of those three polynomials is 6x, y, z squared. So now that we know how to find the GCF, I'm going to show you how to factor it out. Okay, so remember in example 1, we said the GCF of 6x and 9x squared was 3x. So coming down here, we're going to use those two things. So we're going to factor out the GCF from these two things, and it says it's 3x. So when you factor it out, that means that you're taking it out, and it's going to be outside as a multiplication problem. So to find out what's remaining, you're just going to take your original polynomial and divide it by your GCF. So what is 6x divided by 3x? Just a plain old 2, right? Because x divided by x makes 1, and that doesn't matter. Okay, what is 9x squared divided by x? 3x, because 9 divided by 3 is 3. And then remember, when we're dealing with variables, you subtract your exponents. So x squared minus x to the first just leaves us with an x to the first. So this is going to be plus 3x because we get the 3 and the x. So that would be considered factored form. When I look at these two terms left over, is there anything they have in common still? No. So we always want to double check because sometimes we might miss something. Sometimes maybe the value we pulled out for our coefficient wasn't big enough. Okay, and then you can check your work by redistributing. So when we redistribute, we want to make sure we get back our original problem. So is 3x times 2 6x? Yep. And is 3x times 3x 9x squared? Yep. Okay, so I would recommend always double checking to make sure that your multiplication gets you back to the original polynomial. Okay, let's look here. I have 3 terms, 4x to the 5th y minus 12x cubed y cubed plus 4x cubed y. So looking at the coefficients only, 4, 12, and 4. What is the largest factor they have in common? A 4, okay. So the coefficient I'm going to bring out is a 4. Looking at my x terms, so I have x to the 5th, x to the 3rd, x to the 3rd. X to the 3rd, perfect, because y'all told me a while ago I'm looking for the lowest exponent. So since they all have an x term, I can pull out 3 from each one. Whoops, I don't know why I wrote that parenthesis. So I have x to the 3rd. And then what about my y terms? I have y, y cubed, and y. Just a plain old y. So now we got to see what's left over. So you could write this term under each one and simplify each fraction. That's fine. Or you can just compare it to the original. So I'm going to, since I've got this here, write it under each one. Just because for some of you, it's going to help visualize. Okay, so here, what is 4 divided by 4? 1. X to the 5th divided by x to the 3rd? X squared, so I do need to write that. And then y divided by y? 1. Do I need to write x squared times 1? No, so here we don't have to write our 1. Then I see a minus sign, so I'm going to bring down a minus sign. 12 divided by 4? 3. X cubed divided by x cubed? 1, so I don't need to write that. Y cubed divided by y? Y 2, y squared. Okay, plus sign, bring that down. 4 divided by 4? X cubed divided by x cubed? Y divided by y? So these two match exactly, numerator and denominator. So do I need to write anything here? A 1 with a question mark? Did this divided by this simplify to a 1? Okay, so you're saying, I'm going to write it in yellow because it's tentative. We don't know for sure. So you're saying you think I need a 1 right here. So let's talk about redistributing. If I multiply this times x squared, do I get 4x to the 5th y? Yes. If I multiply this times 3y squared, do I get 12x cubed y cubed? Yes. If I don't have this here, is there any way I can get my 4x cubed y back if I don't write this right here? No, because I don't know. If I just have this problem, I don't know that that ever existed. So yes, you are going to have to write a 1 right here so that when you redistribute, you get this third term back. So you need to make sure that you have that placeholder 1 right there. It's very, very important. And that's a common mistake I see. When things simplify to 1, you forget to write them down because you're like, oh, everything cancels out. But really, it just divides out to be a 1. So like, for instance, here, where I had another part of the term that didn't reduce down to a 1, I know that that existed because I have something to distribute to. If everything goes to 1, you have to write the 1. Okay, so my final answer would be 4x cubed y times x squared minus 3y squared plus 1. Okay, see what you can do with number 4. Okay, right here. See what you can do for me on number 4. All right, what did you get for your GCF? What did you pull out? 3y squared, okay? So 3y squared. And then what was left over? 9y fifth plus 4 plus 3. Does anyone disagree with that? What did you get, Anderson? Okay, 4x. So if I redistributed this right here, 3y squared times 4 would only give me 12y squared. So I agree, we do need to have an x right there on that 4. Okay, so this would be correct. Okay, let's say that you didn't think it needed to be squared. Let's say that you were like, oh yeah, 3y is going to be good. So then when I take out a 3y, I'm left with 9y to the 6th, and then plus 4yx plus 3y. Do I still have anything in common up there? Yeah. So that's why I say once you've taken something out, make sure that you have gotten everything. Make sure you got the greatest common factor. So if you see that you still have something in common, you can still bring that out, and whatever you bring out just multiplies by what's already out there. So if you're like, okay, I need to take another y out, you're like, okay, y squared, which makes this a 5, this one would go away, and this one would go away, and you would get what's actually there. So more commonly, you make that mistake when you're taking out your coefficient as opposed to your variables. Okay, any questions on greatest common factor factoring? Okay, next way we're going to look at is just your standard trinomial factors. So this is like when you were in Algebra 1, you're looking for two things that multiply to get you 25, add to get you 10. Okay, so this is leading coefficient of 1, meaning there's no value right here. Okay, so you're looking for two things that multiply to give you 25, add to give you 10. What two numbers is that? Okay, 5 times 5 is 25, yep. 5 plus 5 is 10. So then you would write your factors as n plus 5 and n plus 5. Meaning if we FOILed these out, if we distributed them out, we'd get back to this. Okay, this can also be written as n plus 5 to the second power because you're multiplying this whole thing times itself. Okay, this next one, x squared minus 9x plus 14. So we want it to multiply to be 14, add to be negative 9. Negative 7. You see where I'm getting? You want it to multiply to be the C value. So in our coefficients, you have A, B, and C. So you want it to multiply to be 14, add to be negative 9. You said negative 7 and negative 2. Is negative 7 times negative 2 positive 14? Yes. And is negative 7 plus negative 2 negative 9? Yes. So when we write our factors, you just have x minus 7 and x minus 2. Okay, let's check. If we distribute out, we have x times x, which is x squared, x times negative 2, and negative 7 times x. What's negative 2x and negative 7x? Negative 9, and then I have negative 7 times negative 2, 14. Okay, one more of these. Number 10. So multiplies to be negative 14, adds to be negative 5. Positive 2 and a negative 7. So the only way you're going to multiply to be a negative number is if one is positive and one is negative. Agree? Okay? The only way you're going to take one positive and one negative and add them to get a negative is if your bigger number is negative. So keep that in mind as you're trying the factors. Okay, so I heard a negative 7 and a positive 2. When you multiply, do you get negative 14? Okay, and then negative 7 plus 2, is that negative 5? Yes, so we would write our factors as r minus 7, r plus 2. So any questions about this? Okay, so we're gonna still continue factoring general trinomials like this, except for now we're gonna talk about if there's a leading coefficient, if there's an a value that is not a 1. So all of these, you didn't have any coefficient right here, so you knew that this variable would just go at the beginning of each of your factors.